Right. So what's given in the question that Bob can finish a job in 40 days if he works alone. Fine. Alex is twice as fast as Bob and thrice as fast as Cole in the same job. Suppose Alex and Bob work together on the first day, Bob and Cole work together on the second day, and Cole and Alex work together on the third day. It seems that it's a concept of what alternate days, I think. Okay. And then they continue the work by repeating the 3 day roster with Alex and Bob working together on the fourth day and so on. Then the number of days Alex would have worked when the job gets finished is how many? Fine, nice question. Now it's given that Alex is twice as fast as Bob. Fine. So let's assume A is for Alex, B is for Bob, and C is for Cole. Since Alex is twice as fast as Bob and thrice as fast as Cole. So let's assume that Cole can do 2 units per day, Bob can do three, and Alex is twice as fast as Bob. So Alex will do 6 units per day. Fine. What's the first line? Bob can finish this job in 40 days. What is Bob's 1 day's work? It's 3 units. So what we can say here, total work will be equal to 40 into 3. Bob can do that work in 40 days. So the total work becomes 120. Now how they are going to finish this work? I'll divide the work into three parts. First day, who's going to work? Alex and Bob. This pair will work on first day. Second day, Bob and Cole are going to work. Third day, it's Cole and Alex. Now we can see that Alex can do 6 units per day while Bob can do three. So the very first day, they'll be able to finish 9 units. Second day, B and C will work. That means this pair is going to finish how many units? 3 plus 2 is 5. And on third day, Alex and Cole. So they'll be finishing 8 units per day. So in these 3 days, how much work will be finished? I'll say 9 plus 5 plus 8. That makes how much? 22 units. So can we say in every 3 days they'll be able to finish these 22 units? And if you look at the total work, it's 120. So in the first 3 days, they'll finish 22. Next 3 days, they'll finish 22, and so on. So this 22 should be counted how many times? I hope 5 times. This makes 110 units. So in every 3 day, every person will be working for how many days? Look at this. Alex will work for Bob with Bob in first day, and on third day he'll work with Cole also. Similarly, Bob has worked for 2 days. Cole has worked for 2 days. That means in every cycle, every person must have worked for how many days? 2 days. So I can say that in these 3 days, Alex has worked for 2 days, and I need to count these cycles how many times? You can see this 5 times. So Alex must have worked for 2 into 5, that is 10 days. He has already worked for 10 days, and still some work is left. Look at this. They have already finished 110 units, but the total work was 120. Now, whose turn is now? Alex and Bob will come and they'll work for 1 day and they'll finish 9 more units. That means they've already finished 119 units. Next day, who will come? Bob and Cole. They can do 5 units per day, but the work left is only 1 unit. That means they'll work for one fourth of a day, one fifth of a day. But the question is not about the total number of days. It's about what Alex would have worked when the job gets finished. We've seen that Alex has already worked for 10 days here and he'll work for one more day with Bob here. That means the total number of working days of Alex will be 11 days. So the answer for this question becomes 11. Fine.